A ray of light of intensity I is incident on a parallel glass slab at a point A as shown in the diagram. It undergoes partial reflection and diffraction. At each reflection, 25% of incident energy is reflected. The rays AB and A'B' undergo interference. The ratio of I max and I min is to be calculated. So first of all, we have the intensity of the ray AB is a quarter of the incident energy, which is I. The rest of the intensity is in the ray AC, which would be 3 by 4 I. We can add intensities directly and conserve the total sum, because intensity is nothing but the energy per unit area, and we are simply applying the law of conservation of energy when we say that total intensity has to be conserved. The intensity of the ray CA' is equal to 1/4 of the intensity of AC, and this is equal to 3 by 16 I. Similarly, the intensity of the ray A'B' is equal to 3 by 4 times the intensity of the ray Ca'. Why 3/4? Because this is a refracted ray and the incident ray has 25% of the energy, and therefore refracted ray would have 75% of the energy. This is equal to 9 by 64 capital I. Now what are the amplitudes of these two rays? Since the amplitude is proportional to the square root of intensity, the amplitude of the ray AB can be said to be 1 by 2 into some constant k. Similarly, the amplitude of the ray A'B' is equal to 3 by 8 into the same constant k. When two sinusoids of amplitudes 1 by 2 and 3 by 8 interfere, what are the maximum and the minimum amplitudes? They would be basically 1 by 2 plus 3 by 8 and 1 by 2 minus 3 by 8. And hence we have the maximum amplitude is equal to 1 by 2 plus 3 by 8 into k is equal to 7 by 8k. And the minimum amplitude is 1 by 2 minus 3 by 8 into k, which is equal to 1 by 8k. The ratio of amplitudes of maximum and minimum amplitudes is equal to 7. And since amplitude is proportional to the square root of intensity, the ratio of the intensities would be the square of the ratio of the amplitudes. Therefore, we have I max by I min is equal to 7 square or 49:1, and hence the answer is option A.